How much water should you drink to stay healthy? What happens if you don't drink enough? And is it possible to drink too much? We'll explore these questions today and see what the science says to back up the current recommendations. Hey guys, welcome back. I'm Rich Feldenberg. I'm a pediatric nephrologist, and I create videos about science and medicine. Water is necessary for all life as we know it. In fact, NASA's astrobiology objective of searching for life elsewhere in the solar system uses the mantra, follow the water, meaning that if there's a planet or a moon with liquid water, there's a reasonable chance that life may have developed and perhaps survived there. And people are no exception. We cannot survive very long without water. And that's reflected by the fact that our body has evolved very sophisticated and complex mechanisms to maintain just the right hydration within our bodies. So let's dive right in and see if we can't figure out how much water not only we need to stay alive, but to stay as optimally healthy as possible. The human body is composed mostly of water. We've probably all heard this fact, even in grade school, but remarkably, it is true. The average adult human is somewhere between 50 to 70% water by weight. That difference between the 50 to 70% is based on body composition. So lean muscle mass has a much higher composition of water, about 70%, versus fatty tissue, which has only about 10%. So differences in an individual's body water based on age, sex, or fitness level is usually a reflection of differences in their body composition. Are they a more muscular build or less so? Now, the water within the human body can be divided into different compartments. So the majority of the water in the body is inside the cells. So even though each cell is very small, it contains only a tiny amount of water, because there are so many cells in the body, trillions in fact, most of the water is actually within the cellular space, or what we call intracellular. And the intracellular space is about 65% of the overall water in the body. The other 35% of the water is the extracellular water. And that water can be further divided into the plasma water and the interstitial water. So the interstitial water is usually surrounding the cells and in the soft tissues. It's not in the circulatory space. And the plasma water is within the circulatory space. So for the average 70 kilogram adult, or about 150 pounds, just to use that as an example, that person has 42 liters of water contained within their body if they are well hydrated, and not overhydrated, not underhydrated. And of that 42 liters, 28 of those liters are inside the cell, or intracellular. The other 14 liters is in the extracellular fluid, with 3.2 liters being in the circulatory system, and the other 10.8 liters being in the interstitial spaces. We can kind of use the plasma water as a marker for how the overall body water is doing. Is it in the appropriate amount? Is it too little? Is it too much? Now, to stay in water balance, our intake of water has to match our output of water. And we're losing water all the time. So we lose water in the urine, but we also lose it in the stool, and also in the sweat, and even in the air we're breathing out. So there are respiratory losses of water just by breathing. And all that water out has to be matched by water that's coming into our bodies. And that's water that we're usually drinking, but also there's water in food that we're getting as well. Studies have shown that on a typical American diet, about 20% of our water requirement comes just from the food that we're eating. That's called food moisture. Okay, physiology alert. Now, nephrologists love physiology, but I'm just going to try to keep it to the basics so that we're just going over the physiology that's necessary to understand to answer the question, how much water do we really need to drink per day? So the human body senses water by measuring the plasma osmolality. Osmolality is just a way of measuring the concentration of the fluid that we're talking about. So here you can see the solution with high osmolality. The little yellow dots are the particles, and those could be like sodium in your blood, urea, proteins, etc. And the little blue dots are the water. With the high osmolality, there's more particles, but less water. With the low osmolality solution, there is fewer particles, but much more water present. Now, the human body has a set point where we try to keep the plasma osmolality, because that means that's the right amount of water in our system. Now, a normal plasma osmolality is about 285 to 290. That would be in the green zone here. But if we started to go above the green into the higher osmolality, that means that the plasma is becoming too concentrated and there's too little water in the plasma. We are now becoming dehydrated. So the body keeps the plasma osmolality in this very tight range through a mechanism that involves a hormone secreted by the pituitary gland called AVP, or vasopressin. And the vasopressin circulates in the bloodstream, finds the kidney, and tells the kidney to start conserving water. So we are avoiding dehydration. And the brain not only acts on the kidney, but it creates our sensation of thirst, so that when we become thirsty, that's obviously the way that our body is telling us we need to now go seek out more water, bring it into the body. Okay, so that's our physiology section. Now let's see what the science tells us about how much water we really should drink. Well, fortunately, there have been several scientific organizations that have looked at and studied this problem. One is an American organization, the National Academy of Medicine. Now, they came up with some recommendations to suggest that we should not look at what our minimum water intake should be, but what is called our AI, or our adequate intake. And they have some tables that show the recommendations based on age and sex. The adequate intake for an adult male is 3.7 liters of fluid per day, and the adequate intake for an adult female, 2.7 liters. But they also make it clear that it's difficult to extrapolate to all people, and that's because our water losses can vary from person to person. And that can be dependent on, again, your body composition, but also our dietary intake, the climate that we live in, and the clothing that we wear. And that doesn't account for athletes that are doing very exertional activities. A marathon runner that is running for several hours in the heat is going to be losing liters of fluid. And that's not included in the adequate intake recommendation. All that extra loss has to be replaced on top of the adequate intake recommendation. But based on large population data, they did find when individuals were taking in this much water, they maintained their plasma osmolality in the optimal zone. Now, a 2018 study from the University of Connecticut took a slightly different approach, which is actually pretty interesting. And they looked at how much water it takes to prevent our brain from secreting vasopressin. So in other words, keeping us from activating our defense system. And the reason why this is important is actually pretty interesting. There have been several observational studies or epidemiologic studies that show that when we have chronically elevated vasopressin, we're more likely to also have associated diseases such as diabetes, cardiovascular disease, obesity, hypertension, and even an increased cancer risk. So why should that be? Well, it comes back to the physiology again, or at least there's a plausible explanation, even though it's not been completely proven at this point. So when vasopressin is circulating in the blood and it's acting on the kidney senses that by a vasopressin receptor called V2. And that's what causes the kidney to do its special thing for conserving water. But there are actually other forms of the vasopressin receptor in other tissues. There's a V1 receptor, and that's present on the vascular smooth muscle, in the brain, and in the liver. And it's been shown that when V1 is stimulated by vasopressin in the liver, that causes the liver to produce more glucose, which raises glucose levels. It causes the brain to stimulate cortisol secretion, which is a steroid hormone, and that also increases glucose levels in addition to decreasing insulin sensitivity, and it causes vasoconstriction when it's acting on the vascular smooth muscle. So there may certainly be some merit to attempting to keep your vasopressin levels suppressed. And the way to suppress that is by drinking water. So in the University of Connecticut study, adult individuals that drank greater than 1.8 liters per day had suppressed vasopressin levels, which again was associated with a lower incidence of cardiovascular disease, diabetes, and even cancer risk. Now, anytime you're making a change to your exercise or dietary regimen, you should consult your doctor, because there actually are some conditions where people cannot drink that much fluid. And those are usually problems where there's kidney failure, or people that have congestive heart failure, for example, they may not be able to drink as much fluid as even the 1.8 liters. So talk to your doctor first, but for most otherwise healthy individuals that have normal kidneys and normal heart, drinking enough to keep your plasma osmolality within the normal range is important, but drinking enough to keep your vasopressin levels suppressed may be even more important. Now, is it possible to drink too much fluid? Well, yeah, of course. There's a condition called water intoxication or water poisoning, and that's where an individual has taken in so much water that they've diluted their blood osmolality so much that they can actually have seizures, coma, even death. Now, normally to do this much harm, you need to drink much more than just the 2, 3, or even 4 liters that we're talking about here. These people usually are drinking in excess of 10 liters or sometimes much more than that even. Now, there are some people that need to drink more than just the 2 or 3 liters. And those might be people with, say, a kidney stone to try to prevent stones from reforming, or with certain types of kidney diseases where the kidney is not able to concentrate the urine very well. So if you follow the National Academy of Medicine's recommendations, if you otherwise have normal, healthy kidneys and heart, that should not be too much water. And it may be what's really adequate to keep you optimally healthy. Now, I have some patients that drink so little, they only produce about 300 to 400 milliliters of urine per day. And I'm talking about kids that are actually, they're adult size already. That is so little fluid intake that they're really at risk for some problems like kidney stones and urinary tract infections. That's definitely bad. We know we need to drink more water than that. But I admit that the National Academy of Medicine's recommendations seem like a lot of fluid. And is there a downside to drinking that much fluid? Well, the main downside would be that you're going to have to go to the bathroom quite a lot. You're going to have to urinate often. So it's probably better to drink that fluid during the day than right before bedtime when you might need to get up multiple times to go pee. I mean, that's an inconvenience and that can affect your sleep and your well-being in general. Since the University of Connecticut studies show that having a fluid intake greater than 1.8 liters per day was adequate to keep your vasopressin level suppressed, I think it's probably a good idea to drink somewhere between 2 to 2.5 liters per day so that we're maintaining really good hydration, hopefully keeping our vasopressin levels suppressed. And checking your vasopressin levels is not really a test that you can ask for from your doctor. That's more of an experimental type of a lab value than one that's used regularly in clinical practice. So to know if your vasopressin level is suppressed, well, you can actually just look at your urine. And if it looks very clear and relatively colorless or just light yellow, then you're probably drinking enough to keep your vasopressin level suppressed because your kidney is not trying to concentrate your urine in. So as this is studied more, by future ongoing research, we may get better, more accurate numbers on how much fluid we should really drink. Right now, just as with all science, we do the best we can with the information we have available. But don't be surprised if that may change a bit down the road. So thanks for watching, stay well hydrated, and hope to see you next time. Bye guys.